Okay, so an example here of an engineering system that you could look at with a statistical method. This is a distillation column which has some components which you can then try to put at values which temperatures, flow rates, which makes the process run better. So this is one type of example where you can use the statistical thinking. And when you look at how people do this, in practice there's three ways of doing it. And all of these ways also have their merits. So there is what is called a retrospective study. So say that you have this distillation column, you're running this as a young engineer. You come into the plant and you're asked to optimize the process. You can then look at the historical data, go back a couple of years and try to come up with some indications which will help you to optimize this process. Okay, so that's one way of doing it. This obviously has some advantages with a retrospective study. You don't have to do additional experiments, you're just using information which is already there. It obviously also has some drawbacks because you're just basically faced with what is there, and you may be lacking information which is crucial for you to understand what was happening. And typically as you go back, that's the situation. You don't exactly know what was going on, and the logging system may be very deficient. Okay, so so the trustworthiness of the data may have an issue with this retrospective study. An observational study is a second type of way of doing things. It's just looking at the process. You come into the plant and now you say, okay, I will standardize how we measure the different things, the input variables and the response variables, which we will follow up the process, and then you log that in a very specified and clear way so that the trustworthiness of your data increases. Of course, what is the drawback of this method compared to retrospective? Do you see a drawback?
You require extra time to collect the data.
Exactly. You're this young engineer and you're very ambitious and you want to impress your boss. And so now you tell your boss, yeah, we'll do a 6-month, yes, welcome. Yes. Hadara? Hadassah, I'm sorry, yeah. Hadassah. Thank you for that. Yes, you need some time, and if so you tell your boss you have to wait 6 months, of course the boss may think, okay, I want the answer now. So that's a disadvantage, but the advantage is that your data may be of better quality. If you do a designed experiment, this is a way of setting up experiments which I would call frugal. Frugal means that with a very relatively limited number of experiments. Yeah, who knows the word frugal? Yeah? Okay. Can you explain the word frugal?
Do something the most economically possible.
Yeah, without wasting anything. So that's, is that also how you understand frugal? Okay.
My understanding is it also has like a negative connotation.
It has a
Negative connotation.
Oh, really?
Yeah, so if you don't bring up the word frugal, you don't want to sound like
cheap.
Not cheap, but like things are grim. That's it.
Okay. I use it in my group as well. I say we are frugal because I grew up, well, not really grew up, but I was a graduate student in the US in the end of the 80s. And there was this guy who was cooking on TV who was called a frugal gourmet. So he would make recipes and waste nothing. And so frugal, yes, people may think it may have for some people a negative connotation, but this is a problem. This is the problem of our society. That we think this is negative, that you don't waste anything. Right? So it's a very positive word, shadow. Right?
I'm just like stating what I'd like to see.
Yeah, of course. It's important that we think frugal is good. This is good, and also here it's good. You know, frugal is good because we don't waste experiments. We think ahead of time what experiments we want to do, and so we don't waste. Doing 1,000 experiments if you can do it with 10 experiments, right? I mean, you waste time, energy, money. So this design of experiments is a way to limit the number of experiments and still get the information that you need. So at least it puts you in a mode where you think first about how you're going to do the experiment before doing it. Which is interesting because you can stay thinking all the time before you do something, but at least the methodology is there, and you can follow the methodology and then do the experiment. So it shouldn't get you stuck in the thinking either. But what is the disadvantage of, because everything has advantages and disadvantages, what's the disadvantage of design of experiments if you're working on an industrial installation, for instance?
It's a number of experiments.
They might miss some results.
Yeah, let me first try to understand what we're saying.
I said it's the number of experiments because if I have 4 factors
Yeah.
to 2 to the power of 4,
Yeah.
that's
That's a large number of experiments. If an experiment costs 10,000 euros or whatever in the industry, that can be expensive. You're right. But that's why we say design of experiments can be frugal, because you don't have to do a full factorial, you can do also a fractional factorial experiment. We'll talk about that later. What did you want to say?
So by limiting the number of experiments which we conduct, then we can skip some results, some important results.
Yes, of course. As you go through less and less experiments, you'll have less and less information, so you'll know less and less about the system. That's absolutely correct. But by doing it in a well thought out manner, for the experiments you've done, you've created the most information. Or at least that's what this method claims. So okay, so the design of experiments, I get lost very easily. The design of experiments as well. So design of experiments has this advantage of frugality, I would call it, but also it has this issue that you have to then do experiments if it's on industrial installation, and you may tweak the knobs out of the actual range, and so there's this thing, maybe this is not what we want to do, we may destroy parts or the complete installation, so there is this concern about that as well. So I would say that design of experiments is maybe not done that often on an actual industrial installation, so people would do it more in a lab situation, kind of look at how things are going, but it depends. So it's certainly useful also in actual industrial installation if you want to tweak. You don't know new equipment, you don't know how it's behaving, you know what the operational range is, so you can also do it in an industrial situation. But I can imagine that in certain situations you want to stay away from that as well. So these are possibilities. So I'm certainly not proposing that design of experiments is the only way to go. As we said, this data mining field is something which is kind of exploding at this moment, and so that's basically working on historical data or doing observational studies. So it's certainly not a design of experiments approach there. So all of these techniques are out there.